First off, we've got design, metrics, and monitoring. And now this is a very big infrastructure problem. And what I mean by infrastructure is that like we're not designing something like Facebook. We're not designing something like Netflix. We are like, these are like user-facing kind of things or like apps that you can play around with and that you know. Metrics and monitoring is more computer science-y, in the sense that like we're kind of talking about like the interactions of like computers. And so design job scheduler is like a really big one. Design S3 is also like another big one where we're modeling and creating like our own kind of things for these. And if like, I don't think you should be scared of these types of problems because it's just kind of like a knowledge thing. And also like, I think there's a lot of resources. There's like a really good post on Leetcode that actually goes over this one, job scheduler. But like, if you can do one of these, you can quickly see how you can start conquering and like taking over other ones. Yeah. And so I have my notes, but I'm just going to be going over those. Now, the second thing too, actually, that we're going to do before that is let's talk about what is metrics and monitoring. So I don't know if you guys have heard of Grafana. That's really popular, or Splunk, or what are some other data kind of querying things, but like essentially these are used for monitoring applications. And if there's like a server spike, so they'll monitor CPU usage, they'll monitor RAM for all the application, they'll have all of your logs. They'll have all of your logs that you can like see. And if alerts are like too high, then on your servers, well, then you can set up like an on-call or like an alert trigger. And so essentially like you are always aware. The benefit of building something like this is that like you are always aware of when your application is going to crash, of when things are burning, and you can adjust and pivot, so to speak. And so the kind of idea behind this one is that like we want to build this essentially. And so we're going to be storing things like let's go over the requirements to be functional requirements. So we're going to store things like CPU usage, RAM usage, can be things like, I don't know what else. Let's store them 4 years, and then also users can query data for servers. So let's say they want to know what was the CPU usage 2 weeks ago. Well, you can tell them that, right? We want to keep track of all of those things. And let's see here. I think that might be it. Oh, here's some other ones too, by the way, because I see these in my notes. Influx, DB. We have Datadog and all of these things. And we also, let's say disk space too, actually. So CPU usage and like disk space. So how much hard drive, memory and all that stuff is there. And let's say requests per second too, actually. Store requests per second. And then what's the scale of this? We'll talk about that later. We'll keep data for 4 years. And we're also going to allow for alerts. So users can ping for alerts and don't need logs. So these are the requirements for this, is that we're going to start running through building out a system like that can do these things. And then the non-functional requirements. Kind of curious if anyone can chat, can like think of any non-functional requirements that would be clear, stand out for this. Possibly, maybe. I'll just give it a little bit of time if anybody wants to say what are some non-functional requirements for this. Cool. I guess I'm saying what the non-functional requirements are. So one thing is that we never want to lose data. That would be really bad, right? If we were losing data, that would be really bad. So we never want to lose data. We need our metrics to be almost 100% accurate. And I think we want to prioritize availability over consistency. It's okay to have duplicate data, but we just never want to lose data when we're building out something like this. And this is going to be very high scale, which I didn't reference, but like this is high scale. It's a very high scale system. So let's say we're at a $1 trillion company. We're at Oracle, that's almost approaching $800 billion. I think the founder or something is like now the richest person in the world, but we're going to be going over that, and we're going to be at that kind of level. That's it. We just never want to lose the data and keep that there. So let's mark these in maybe blue. I don't know if that's a nice color. And then go into the second one, which is backup envelope estimations. So what we'll do is we'll say that we have 100 million daily active users, and we have 1,000 server pools, and each of these 1,000 server pools will hold 100 machines. And what does that mean? That means that how many servers do we have? So we've got 100 machines, 1,000 server pools. So this is going to be 1,000 is 10 to the third, and then we can multiply that by 10 to the second, right? So there's 2 zeros here. With that, we know that we're going to have 10 to the fifth servers. So we're going to have 10 to the fifth servers. Now, let's say that those servers are going to be sending out data every single second, and we're going to be collecting that data. So then we can say every second that they'll be sending out data of what their request per second is, of what their CPU usage. I think, do we want to do it by the seconds, or is that too crazy? I think it's fine. And so then let's say that these machines We have 10 to the fifth machines that as we've seen, 10 to the fifth is 10,000, or not 10,000, it's 100,000. Count the zeros. And then we have machines. So then the machines are going to be like the queries per second. The write QPS will be 10 to the fifth, 10 to the fifth per second. Sorry. So it's 10 to the fifth per second. Actually, let's say we're just going to do it per minute. let's decrease this per minute. Okay. So then per minute, that means that we've got 60 minutes, convert the 60 minutes into hours, and then convert the hours like times 24 to get how many are in a day. Or hold on, we want QPS, well, queries per second. This math is crazy. We have 10 to the fifth queries per minute. I mean, actually, okay, hold on. We could do queries per minute, and then we just divide it by 60 to get seconds, queries per second, which it would be like 10 to the fourth for QPS. So it's not like really a big deal. But anyways, let's just call it, let's say we're sending it out every second, actually. That was backwards of me. So QPS is 10 to the fifth for this one, which is quite big. And then the daily active users. So we're going to have people who are querying data. So all the software engineers of the company, other users are also going to be querying stuff. Maybe, we've got other pipelines. And so what we'll do here is we'll say that, like, let's say the average user is making one query. I think a day might be fine. I don't know, actually. What's the assumption here? Is it, I don't know. Yeah, let's just say it's average person searches for queries maybe twice a day or something. So then we would have a QPD, queries per day. And this is million is 6. That is 6 zeros, 7, 8. So then we have 10 to the 8th. And then we can convert QPD by dividing by 5. So then that would be 2 to 10 to the 3rd, because there's 10 seconds in a day, or 10 to the 5th seconds in a day. So then it would be 10 to the 7, 6, 5, right? So QPS is 10 to the 3rd. That makes sense to me. Wait, 8 minus 5, 7, 6, 5, 4, 3. I got my math. Cool. Okay, so that took a while. Cool. Now that we've got the back envelopes done, which we can write out here. So the read QPS. So then we can go into the actual kind of entities, I think, and which I like, because this is going to help us store the databases, and it's going to help us manage the tables. And so we're going to have the data, I would say. So CPU usage, RAM usage, and the server. That's going to be like another thing. We have servers. We'll have like a server pool, perhaps. And what else do we have? Server pool, maybe the usage. Or I don't know what you'd call it. Like, I don't know, server metrics. We can store server metrics, server pool. I think these may just actually be it. I think there's probably also going to be users because we do want to actually send out alerts to them, but I think that's probably fine. Cool. Okay. And now let's go into just high level design of how do we actually set this up. If we're following Hello Interview, we would actually do the API routes, I think. Actually, no, he doesn't. He doesn't for infrastructure. He skips them for infra problems. So we'll just go into the kind of high level design here. So let's say we've got a ton of servers that we kind of mentioned, right? So we've got this one. All of these servers are going to, let's say they send out their data to some kind of metrics collector. And so the servers are all going to be pinging them, sending them out to some kind of API, some kind of URL, or it could even be a gRPC if we want to, get fancy with it. Instead of using HTTP, we could just use gRPC. But we want to send these out. And so we're going to be sending out all this data into this metrics collector. And this is going to start categorizing them by these tables, right? So we have the entities that we want to know, and this is going to really, really help us with forming our table. Question here too is, which database should we use? Because we actually have a lot of writes that we're doing. So 10 to the 5th writes per second, which is a lot. And we could use relational, and we just split all the databases out. So we've got maybe 1,000 servers that we have, and we lock each of the server pools. Maybe one server pool gets its own database, its own relational database, and we can play around with that. But retrieving from a relational database is actually going to be annoying. So again, we can give each server pool their own relational database, which hopefully that makes sense. Is that because we cannot do 10 to the 5th on one single relational database, just writing. The machine would crash. It can't handle 10,000. It cannot handle 10,000 writes per second. And so what we have to do is we would have to split each of the machines out onto, each has its own server pool, so that drastically lowers it. So maybe each machine is doing 10 writes per second, which is totally doable for a SQL machine and server. And the part's going to be the reads, because when we have metrics, well, I want to know what happened at this date, with this date, with this date. I want to know what happened 2 weeks ago. And the idea there is that we can actually use a time series database. So what we can do is we can use a time series database, and that's going to allow us to, it's already kind of organized and useful, like set up for those retrievals. There's also NoSQL, but again, NoSQL is also going to be rough for doing timed queries, date ranges, and all of that kind of stuff. So we can set up with a time series database. It's going to be able to handle the write throughput. It's also going to be way more efficient. Have some kind of algorithm properties. I actually have no idea. This is something maybe I could explore, but into the future on how this stuff works. But it does have properties that make it just nicer for reading, and it's already built in. And so these types of databases look like, let's see, what are they called? To give you guys some examples. So there is OpenTSDB, Metrics, DB, Amazon offers TimeStream, and then we have Prometheus, and we have InfluxDB. We have tons of options. Obviously there's more than what I've just written out here, but the big idea here is that you guys, like, if you ever wanted to build this out for real, you could for sure do it, and most likely for very, very, very cheap. So we do have our DB, and then we're going to be storing these things. So we're going to have like server ID, server pool ID, server metrics, and it's going to have like the time that it got that metric and everything. Now we can have so there's an interesting kind of thing that we can do, right? Which is like metrics retriever. And so we can have a user who wants to grab metrics. And so we just have them ask the retriever. So we have like a microservice kind of architecture, and where we split up the work for different, kind of bundles and different teams and different groups. We can use have that query the database, like just directly. Now, something you may find interesting is that like we're going to be writing to the database, and we're also going to be reading from it, which maybe is a lot. Maybe it's annoying. Maybe something weird happens, and like as all of these writes are kind of happening into all these databases, and so it may actually just be better, because we're putting in a ton of reads. It may be better for us to just separate them, and we actually do an analytical query. So we have a database that's like, this one is for the raw data. And so this one pulls from like the raw data, and then it stores that data into this analytics one. And I think this has like a couple of, again, I think it has, a couple of benefits. So one is that because we have an analytics database, which you can't see because of my face, but because we have an analytics database, what we can do is we can run the queries and read from them perfectly fine. And then we also get access like just to raw data. So if there is a mistake, we can actually just dip into the raw database and clear that up. So then we can just have raw data, like just kind of just sitting here unprocessed. Other things here too that we could actually talk about that's unique to this problem is that like, okay, so I just mentioned that like we just push all of the data into this metrics collector, but like what if we reversed it and we have the metrics collector like pull the data? And like one thing you'll notice is that like, what do we do if one of the servers like breaks and they stop sending data? What do we do? Also, we would actually have a load balancer here, by the way, load balancer, coordination service, because if one of these things breaks, we need to know, we need to be able to fix it. And that's going to be really, really huge for us to be able to do. And so we need some kind of load balancer or also a metrics, a coordination service. So we would have something here that's going to be making sure that none of the servers are down, and then it can reboot them if that is the case. And other thing here is that like, what if we push too many metrics to the collector? For designing metrics monitoring, the push pull method is like something that's really, really big. And so what we want to do is we want to, when you're sending it, you can either have it send the data to the collector, or we can actually have it just retrieve and pull data. And these are going to be two different things, right? So like at scale, this is really hard for us to manage. We've got tons and tons of servers all pushing into one spot, as opposed to like pulling. It's like really easy to know when something's broken because it just never pulled it. But it's harder to know when something isn't pushing data. Or if the server goes down, now we've got to reroute it. Now we have to like remove the server from, this other ID, and we have to replace it and replace the data here. If it just pulls in from one location, this logic here is easier to manage. Also having like firewalls apparently makes pulling easier. Actually, I guess feel like for all like the purposes, like pushing is actually just better. It's just better to just push. But I do think there are pros and cons to it. Health checks are also harder to do. So if there are health problems with this one, well, then we should probably like reverse it. So cool. We talked about raw data and analytical data. Good. We do want to, like, when it comes to sending the data, we want to use Kafka, because Kafka can guarantee that we actually don't lose anything. We don't lose data. And that's really, really important with this. So as we're sending data from the metrics collector, from this database, to here, we want to have Kafka. We want to have Kafka. Like we'll have like some workers. We can call them like little workers, and then they're going to be pulling them and sending them into Kafka. And so that's how this is communicating. The workers are here, and then we've got Kafka, and then Kafka is going to send it to the server. And this is going to guarantee the data does not get lost. And So this causes delays, but then you can also use real-time kind of data transfers. So we can use Apache Storm, we can use Splunk, we could use Spark and start pulling in like just real-time data if we did want that. But Kafka will cause delays, but it has massive throughput, which is phenomenal, and also guarantees, messages aren't dropped. And cool. So we have our ingestion service, the query service. We can also store query results. So when we're doing metrics, we can have the paging kind of service. We can have an alert service. And then this alert service can tell us when something's wrong. So it can start running queries and then tell us if something is wrong here. And then if there is something wrong, it can actually just start paging you at 2 a.m. to let you know, hey man, you got to get to work and fix this. Then we've got like PagerDuty and other stuff. So that is that. And then that will go here into PagerDuty, which will go directly into your cell phone. Cool. And PagerDuty, and then it will call to me. And there's other things we can talk about, which is like compressing this raw data. So eventually this is going to get too big. So we can actually separate it out into cold storage. So this is the idea that like when data is, if we're not going to be using this raw data anymore, let's just put it in farther away and isolate it into like a hard drive disk. Using the same kind of thing with the workers, right? We can transfer them over and have new workers, but they transfer it over and we have cold storage. So it'll take about, a day to search through and find the data that we're looking for, but then we can go pull it and give it in for the analytical queries if somebody does want to query something from 5 years ago. So this is design metrics and monitoring. And hopefully, again, the big thing with this is that we understand how to use Kafka. We understand the idea between raw and analytical data. We understand what cold storage is and how to use it. We understand how to use alert services and connect to other services. And we know coordination services. We know how to do back available estimations, how to use load balancers, and so on. So that is that. And I am done with this one. And we'll see you guys again on Saturday when I go over another kind of problem. But that is that for today. So cool. Hopefully this clears stuff up. Hopefully you understand, again, just how computers are working and all that. I'm still here though, but we're going to end it for